Today we're going to take a look at implicit differentiation. So let's take a look at part 1 on our worksheet. We're talking about explicitly and implicitly defined functions. Now this one, for the directions, we need to find y prime. So we would just use the power rule, and the derivative is 6x. But for our second function over here, xy equals 1, in order to find y prime, we would first have to solve for y. So we'd say y is equal to 1 over x, or x to the negative 1, and then y prime is negative 1x to the negative 2. Then for the third one, in order to find y prime, again, we'd have to solve for y, but you're going to find as you do this that your algebra is going to fail you a little bit. 2 minus x squared, and then wherever you go from here, you're not going to be able to isolate y. So in order to find y prime, we're going to need another technique, and that technique is implicit differentiation. So this equation here is implicitly defined. That is, we know that we can write y in terms of x, we just don't know how to. Over here, backing up a little, xy equals 1. This here is also implicitly defined. We were able to rewrite it, though, as an explicit equation. And then our first one, this guy over here, is explicit because we know exactly what y is equal to in terms of x. Okay, moving on to part 2, implicit differentiation. So if we want the derivative of x cubed with respect to x, that's no big deal. We know how to do that. That's just the power rule. But if we wanted to find the derivative of y cubed with respect to x, that's a bit of a different story. So we can still use the power rule, except we want to remember that y is defined in terms of x. So to find the derivative of y cubed with respect to x, we'd have to use the chain rule and multiply by the derivative of y with respect to x. Now we don't know what this is, so this is really the best that we can do. The derivative of y cubed with respect to x is 3y squared times the derivative of y. Okay, moving back up here. Okay, let's split this up here. We can look at this as the derivative of x with respect to x plus the derivative of 3y with respect to x. So this we know, the derivative of x is equal to 1, but then we've got the derivative of 3y with respect to x. So we take the derivative of 3y using the power rule. We get 3. And the derivative of y is just 1, but then we've got to multiply by the derivative of y with respect to x. And again, we don't know what this is, so we leave this as our answer. Okay, last one. Notice we have a product rule. This is x times y squared. So we're going to start with the first times the derivative of the second. So the derivative of y squared is 2y, but then we've got to use the chain rule, plus the second times the derivative of the first. So this is it. The derivative of xy squared is equal to 2xy dy dx plus y squared. Okay, so part 3. There it is. Okay, find dy dx given x squared minus 2y cubed plus 4y equals 2. Now this is a little different from what we were doing before because now what we have is an equation. So this is how we go about it. We're going to take the derivative of each term. The derivative of x squared is 2x. The derivative of negative 2y cubed is going to be negative 6y squared. That's the power rule, but then we've got to use the chain rule and multiply by the derivative of y. Plus, the derivative of 4y is 4. Use the chain rule, multiply by the derivative of y, and the derivative of 2 is just plain old 0. Now the directions are to find dy dx. So we have to solve for dy dx. So I'm going to move any term with dy dx to the left and everything else to the right. So we're going to have negative 2x on the right. Then we can factor. So dy dx is negative 2x all over negative 6y squared minus 4. Okay, on the same page we've got another one similar to this. Finding dy dx, 3y squared, chain rule, plus 2y, chain rule, minus 5, chain rule, minus 2x is equal to 0. Again, solving for dy dx, we'll move the 2x to the right side, and then we're going to factor out dy dx. So our derivative, our y prime, is equal to 2x over 3y squared plus 2y minus 5. Okay, on the other side of your sheet, we've got 4 more problems. And this here is just kind of a reminder that our functions are not going to always consist of these nice little monomials. So if we want to find dy dx here, we do the same thing. We're just going to take the derivative of the left and the derivative of the right. So the derivative of sine we know is cosine, but then we've got to multiply by the derivative of y, and the derivative of x is just 1. So dy dx is 1 over cos y, or if you prefer, just secant y. Okay. Now we've got this nice little circle, and we have to find the second derivative. So second derivative of y. So same thing, the derivative of x squared is 2x, the derivative of y squared is 2y dy dx, the derivative of 25 is 0. Solve for dy dx. So our first derivative is negative 2x over 2y, or negative x over y. But now we need the second derivative. So we need the derivative of the derivative. Here we've got a quotient, so I'm going to use quotient rule. If you want, you can make this negative x times y to the negative 1 and use the product rule. It's up to you. So our second derivative is the denominator derivative of the numerator minus numerator, that should be a negative 1, minus the numerator times the derivative of the denominator. So the derivative of y is going to be 1 times dy dx, and this is all over the denominator squared. So let's simplify this up a little bit. This is negative y plus x dy dx over y squared. And we know what dy dx is. We found that before. That's negative x over y. So let's substitute that in. Negative y plus x times negative x over y all over y squared. Okay, simplify a little more. We've got negative y minus x squared over y all over y squared. We've got a complex fraction. It's a fraction within a fraction. Our common denominator is y, so I'm going to multiply each term by y. So So our first term will be negative y squared. In our second term, these y's will cancel, so we'll only have negative x squared, and the denominator will be y cubed, and we are almost done. We can simplify this a little bit more by factoring out the negative. And you may wonder what this does for us, but you see this y squared plus x squared? Well, we know something about y squared plus x squared from what we're given. We know that x squared plus y squared is equal to 25. So y squared plus x squared must also be equal to 25. So we get negative 25 over y cubed, and that's the second derivative of the given equation. Okay, two more example problems. Okay, determine the slope of the line tangent to the graph of the given equation at the given point. So again, we're looking at derivative. So 2x plus 8y dy dx is equal to 0. This means that 8y dy dx is equal to negative 2x. So we get negative 2x over 8y, and if we simplify, that's negative x over 4y. So now if we're going to evaluate this, at this point, all we're doing is a little substituting. So we want to find dy dx such that x is radical 2 and y is negative 1 over radical 2. So that is negative x over 4 times negative 1 over radical 2. Let's simplify this a little bit. We've got radical 2 over 4 over radical 2. If we rationalize, we've got 2 over 4, which is 1/2. Okay, one more. Now we need the equation of a tangent line. And what I'm going to do with this stuff on the left is I think I'm going to distribute this. Let's make this x to the 4th plus x squared y squared equals y squared. Here we need the product rule, so first derivative of the second derivative of the first. Dy dx is on one side. Everything else on the other, so we'll have negative 4x cubed minus 2xy squared. Let's factor our dy dx. So the slope is negative 4x cubed minus 2xy squared all over 2x squared y minus 2y. Now it looks like we've got a common factor of 2, so let's get rid of that. Okay, so now our coordinate is radical 2 over 2, radical 2 over 2. So we're looking for the slope when x is radical 2 over 2 and when y is radical 2 over 2. So negative 2 Okay, so negative 2 times 2 radical 2 over 8 minus 2 radical 2 over 8. And there are lots of ways of going about this. I kind of feel like multiplying everything just by 8 to cancel out all those denominators. So we'll have negative 4 radical 2 minus 2 radical 2 over 2 radical 2 minus 4 radical 2. And we get 3. So the equation of our tangent line is y minus y1 equals 3 times x minus x1.